Hello everyone, my name's Kate Stanley. I'm very excited to be here at JSpring again. This is my second JSpring, but it's actually my first international conference in quite a while, so I'm very excited. And today I'm going to talk about what you can learn from Connect's use of Kafka. So I'm a software engineer, I work at Red Hat on all things related to Kafka, and then I sort of speak on the side. So what are we going to talk about today? Well, I'm going to do a little bit of a Kafka intro just to make sure we've got some terminology down. And then I'm going to talk about how Connect uses Kafka topics and quite a bit about rebalancing. What I'm hoping you'll get out of this session today is that if you're already interested in Kafka and Connect, you'll get a little bit of a look under the covers of how it works and also some of the decisions that the Kafka community have made when they've been building Kafka and Kafka Connect. But if you're not so interested in Kafka and you're just kind of curious to see what the Kafka project is up to, then I think there's some really interesting lessons here on how you can build APIs and protocols that help you in the future. So let's start with Kafka. Who in the room here already knows what Kafka is? Quite a few people, cool. Anybody using it in production? Yeah, quite a few, cool. So I'm not going to give an intro to Kafka in this session. I do not have time for that. So I will do a quick, here's some bullet point definitions that hopefully we're all familiar with, so that throughout the rest of the presentation, if I say words, hopefully you know what they mean. So Kafka is an open source distributed event streaming platform. Hopefully you all know this. It's mostly written in Java and Scala. And when you send data into Kafka, you send it from applications called producers, and you take the data out using applications called consumers. A Kafka record is the actual data that we put into Kafka, and it's made up of a key and a value. The key is actually optional, and we'll see how they're useful a little bit later, and the value is where you put the bulk of your data. All of these Kafka records get put into a topic. So this is a series of events. Although actually under the covers, a topic is broken down into one or more partitions. So here you can see we've got topic A with 3 partitions and topic B with 2 partitions. And the whole of Kafka is distributed. So you run a Kafka cluster with multiple brokers. So here we've got 3 brokers making up our Kafka cluster. These are each just a Kafka instance running, and all of your topic and partition data is then spread across your Kafka cluster. So there's one other element that I want to quickly recap on in case you're not familiar. And that's how consumers work, and this will be interesting later on. So one of the key features of Kafka and why it's different from other messaging systems that you might have come across is that it provides persistence. So this means once a consumer reads message from the Kafka partition, it's still there. It can be reread, multiple consumers can read at the same time, and you can move about within the partition. So this raises 2 specific questions. What happens after my client restarts? In other message queues, once the message has been read, if the application goes down and comes back up again, it would just read the next one along. But in Kafka, consumers need a mechanism to know where they've got to in that stream of data. And they do that using offsets. So each record that's sent into Kafka is given a number, and this is its offset. And what the client can do is it can commit that offset to Kafka, and in reality, that just goes on a topic somewhere. The second one is, how can you share consuming? And that's done using consumer groups. So say I have a set of applications, and I've got 2 applications that between them I want to read all of the data on a topic, and then 3 different applications that also need to read all the data between them. Well, in Kafka, when I start up my consumer client, what I can do is provide a group ID. And all of the applications with the same group ID will be collected together into a group. Then these groups are provided the different partitions. So group 1, between the 2 consumers, will get all of the partitions, and the same is true for group 2. It's worth noting here that the way this works is we're basically assigning a single partition to a particular consumer. So if I add an additional consumer to group 2, it wouldn't get any data because there isn't a partition for it to read from by itself. So that's my whistle-stop tour of Kafka. If you want to know more details, I've done other previous talks that are available on YouTube that go into a lot more depth, but hopefully that gives you a bit of an idea of some of the terminology that I'm going to be using throughout this presentation. So let's talk about Kafka Connect. Who here is familiar with Kafka Connect? Ah, not that many, okay. Are the ones who are familiar using it in production or no? There's one person, nice. Okay, so this is the bulk of this talk. So Kafka Connect is a part of the Kafka project that allows you to get data into and out of Kafka. So flowing it between a source system or a sink system. And Kafka Connect has these three features. It provides you a consistent way to get data in and out. So you only have to understand Kafka Connect. You don't necessarily have to understand all the different external systems you're integrating with. It's pluggable, and it's resilient. So let's look at these two things in more detail. How is it pluggable, and how is it resilient? So when you first get introduced to Kafka Connect, as you are today, you'll often find a lot of people talk about having a source connector and a sink connector. The first thing you do when you start up Kafka Connect is you create a connector. A source connector takes data from an external system into Kafka, and a sink connector flows data from Kafka into the sink system. And when you actually run commands against Connect, start flows of data, a connector is the term that you'll hear most often used to refer to what you're doing. But actually, under the covers, it's a little bit more complicated than that. So this is what a flow actually looks like. And I've used double-ended arrows. You can think of this as being both a source flow in one direction and a sink flow in the other. So what makes up a connector? Well, we first have a converter. So this converts the data from the format that's going to go into Kafka to an internal Kafka Connect format that can then be processed by the other parts of Connect. Then we have some transforms. So this allows you to change the data as it flows through Connect. So you can do things like change fields, rename fields, perhaps remove fields. And then finally, we have the actual connector. So this allows you to get data into and out of the external system that you're trying to connect to. And Kafka Connect has been built on a very simple principle, which is that you should be able to run as many different flows as possible without having to write a lot of code. And the way they've done that is by making it pluggable. So each of these parts, the converter, the transforms, and the connectors, these are all pluggable parts of Connect. They're all in the underlying code, they're interfaces that you can implement. So when you start up Connect, and you start a specific connector flow, whether that's source or sink, you provide a few things. You provide your connector class. So in this case, I'm using the file stream sync connector, so I'm getting data out of Kafka and into a file, and then I've got a converter and transforms. You can then use any that have been provided by the Kafka community for each of these classes. So you've got some examples here. But if you want to write them yourself, then you can. And Connect makes it really easy for you to provide those. You just add the jar files that you've got for them to a plugin path, which is a set location within Connect, and off you go. So I think this is a really interesting choice for Connect. It's something that they haven't done as much with Kafka. Kafka is pluggable, but not to the extent that Connect is. So it allows you to make use of existing connectors that have been written by Kafka, or connectors, converters, and transforms that have been written by those external systems, or you can write your own. So now let's talk about resiliency. I'm going to give a kind of brief overview, and then we'll delve into rebalancing. So in Connect, we have workers. So it's, again, a distributed system. So when you run Connect, you run one or more Connect workers that make up your Connect cluster. And a worker is just an instance of the Connect runtime. It's run in a very similar way to Kafka, so you're obviously all familiar with Kafka. And so the way you would start up a broker, you start up a Connect worker in a similar way. And the Connect workers will then run between them a set of connectors. And one of the things that makes Connect resilient is that if a specific worker were to go down, it's got inbuilt mechanisms to allow it to redistribute the data amongst it. And that's one of the things that I'm going to be focusing on today. So let's talk about Connect and Kafka. I've already talked about how Connect is really pluggable, but how does it actually make use of Kafka in ways that you might not expect? So firstly, Connect obviously sends and receives data to Kafka. That's the obvious one. We're not going to talk too much about that. Once you're setting up a flow, that's the kind of core aim. But as part of Connect's running, it actually makes use of compacted topics and group rebalancing in quite a lot of detail. So let's first look at the compacted topics and why Connect uses those. So who here is already familiar with compacted topics? Not many people. Cool, okay. So I mentioned earlier that we have a key and a value within our Kafka records. So here we've got the key at the top, and the value I've just put some sort of JSON value. That's not really anything to worry about for compacted topics. We're going to focus on the keys. So Kafka records aren't kept in Kafka forever. You can keep them there for a long period of time, and once a consumer reads them, they are still there, but eventually they will get cleaned up. And if you create a default topic, Kafka will start cleaning them up from the beginning. So if we've got our offset as 0 to 4, in this case, it will just start from the beginning and clean them up. But a compacted topic allows you to inform Kafka to clean up your Kafka records based on the keys that you've been using. So you can see here I've got a few different keys. I've got key 1 twice, I've got key 2 only once, and then I've got key 3 twice. So what Kafka will do is it will elect to clean things up so that it always leaves a record with a specific key left over. So in this case, you can see we've got duplicates of key 1 and key 3. So both of these records, Kafka can go ahead and remove. So how does Connect use compacted topics? Well, we actually have 4 topics that it uses. The consumer offsets topic, the Connect offsets topic, the Connect configuration topic, and the Connect status topic. So let's look at the first 2, which is all around how we store offsets. So Connect is designed so that if a specific connector, and here I'm kind of talking about the whole thing, converters and transforms and everything, if that were to go down and come back up, it should be able to carry on where it left off. When we're running with a sync system, this actually is pretty straightforward. Kafka Connect is doing the actual work of getting the data out of Kafka and passing it to the sync connector, and it needs to know what offset to use, but it's just running a normal Kafka consumer. So it can just do an offset commit every time it gets the records through, and that under the covers, I said it goes to a topic, which is the consumer offsets topic. But it's actually the source connector flow that I think is a little bit more interesting. So for a source connector, you want to know where in the source system you've got to. And obviously this depends on the source system itself. Does that have a mechanism to help you keep track of what's going on? How does that work? But what they decided to do for Connect is say, actually, we think it should be Connect's responsibility to understand where you've got to in the source system. It shouldn't be just something that the source system worries about. So what they've done is they've added a mechanism so that when a source connector gets data out of the system, it passes it through to Kafka Connect as a source record. So this is the Java class that you would see. And it has 2 fields in it, the source partition and the source offset. Now, these are named slightly confusingly because they're actually nothing to do with partitions and offsets in Kafka, but I think they wanted to have that kind of similar feeling between the 2 directions. But from the source connector's perspective, basically, it can use the source partition and source offset to put in some representation of where it's got to in the source system. So that information is then produced by Kafka Connect to Kafka, and it's put into the offsets storage topic. So it's actually working similarly to how the sync connector would work, but it's doing an active produce rather than using the offset commit mechanism. So why did Connect make this choice? Why is this useful? Well, it's enabled them to actually add exactly once to the source flow. So this is a capability that's been voted. It's going to be added to Kafka. They're currently developing it. So if you run today with Kafka, you won't see this, but it's coming very, very soon. So what does exactly wants mean, and why was it needed to be added? Well, if you think we've got two operations here. We've got the actual sending of the data, which is represented by the little red square, and then we've got committing the offset. If we only send the data, and then we later try to commit the offset and fail, if the connector goes down and comes back up again, it wouldn't know where to carry on with, and it would repeat that one message. So at that point, we don't have exactly once because we have a duplicate. If we just commit the offset and do that first, but then somehow fail in sending the message, then obviously we've missed a message. If the connector goes down and comes back up again, it would move on to the next offset. But Kafka allows you to do transactions. And because these are both produce requests, one of them being the actual produce of the data, and the second one being to that compacted topic, in the KIP 618, they've made it so that both the offset and the produce happen as part of a transaction, and now we get exactly once. So although initially it might have seemed a bit of an odd choice to have all of this managed on the Kafka side rather than in the source system, they've been able to make use of other features of Kafka to make Connect even better. So there are two other compacted topics. One of them is the configs topic. So I've provided here the commands that you can use to have a look what's going on inside your two compacted topics. So you can see here we've got connect configs. So the bit in red here is the key. So you've got connector file sync, that's a connector that I have running, and then we've got all of the configuration for my connector. So if you haven't seen Connect running before, this is the configuration that I would provide to start a specific connector. So I've got things like the connector class, which topics I'm going to be sending data to, the file I'm reading from. And the second one we have is the connect status. So this one here has got the status for the connector file sync. For both of these, there'd be multiple records on the topic with the status of different things. And this is used by each of the workers because you have a REST endpoint that you can call in Connect to find out the status of a specific connector. And the nice thing about this is by storing all of this information, both the configuration and the status, inside of Kafka, instead of locally inside the worker, it means that all of the workers can get this information and then immediately respond to requests. If worker 1 is running the connector you want to know about, you don't actually have to talk to that worker. You can talk to anyone else that's in the cluster. So these are our 4 compacted topics that Connect uses. It's very worth being aware of these because if you run Connect multiple times, you'll have to clean these up between runs because the data's persisted. But why use compacted topics? Why is that useful for this sort of data? Well, all of the data in these 4 topics is information that is a sort of point in time. What's the current offset? What's the current config? What's the current status? So if we have lots of records in our Kafka topic, and even though they get cleaned up, they can get really big. If our workers go down and come back up again, then they have to read all of this information to catch back up. The benefit of a compacted topic is a lot of these records will get cleaned up. You're guaranteed to have the last update for the specific thing you care about, so whether it's the specific connector or whatever, but you have a lot less records to read. Okay, so let's talk about groups and rebalancing. And for me, I think this is the most interesting thing that Connect does. So why do we even need rebalancing? So when you start a specific connector, in Kafka, you use a REST endpoint, as I already mentioned. So this is an example. So we've got curl request to our worker, and we're creating a connector called myConnector and providing some config. And the config will look similar to what I showed in the previous slide. What then happens is 2 things get created. First, a connector, and then some tasks. So I haven't really mentioned what tasks are yet. The connector is the thing that sort of coordinates the fact that we've got to flow data from one place to another. But the tasks are the things that actually do the work. So if I'm running with a file connector, the task is the one that's actually reading the file or writing to the file. The connector just decides how many tasks to start and what configuration to give those tasks. And all of these have to be distributed across the different workers. So this isn't a difficult problem in itself. We just spread them out and then we're done, right? Well, what if we add another worker? What if we add another connector and another task? Kafka Connect is designed so that you can run lots of connectors with many tasks underneath. So we need a way to dynamically be able to move these around if particular workers come and go, or we need to redistribute the load. And actually, this is a similar problem to one that already exists in Kafka, which I sort of mentioned earlier, which is in the Connect mechanism, we've got workers, so clients, that have resources, connectors, and tasks that need to be distributed. For consumer groups, we have clients, which is our consumers, and they have partitions, which are particular resources that need to be distributed amongst them. And both for Connect and for consumer groups, we have this grouping of similar clients. So you can actually run lots of different Connect clusters that all talk to the same Kafka and just have them work between them. Similarly, as you can have multiple different consumer groups all connected to the same Kafka. And Kafka have solved this using rebalancing. So they decided to come up with a mechanism that would work across both different use cases, and that's what we're going to look at now. So they decided that this mechanism needed to have, firstly, the ability to handle group membership. They wanted both for Connect and for consumers to be able to define these are the clients that are part of this group and need to have these specific resources spread amongst them. Ideally, they wanted to have resource assignment done in a single place, rather than having multiple different things trying to work out its assignment. And then you need a mechanism to hand out all of those resource assignments amongst the group. It's worth noting, what I'm going to do today is talk you through generally how it works, and then an update that's come in. But actually, there were multiple iterations of this group and rebalance in Kafka. They didn't get it right first time, they had to iterate. And there are 3 different roles that I'm going to talk about. So we'll have a group coordinator that coordinates who's actually a member of the group. We'll have a group leader, and we'll see what they do. And then we have the general member of the group, which is a specific client. So before I talk about membership, I just want to talk about the Kafka Protocol. Is anyone here looked at the Kafka Protocol much before? A little bit, like a few people. So I'm just going to give you enough information so you can see a little bit more how the rebalancing works. But if you're interested, feel free to go have a look on the website and in detail. It's really interesting to see how they've built this all up. So it's a binary protocol over TCP. All the APIs are request-response pairs, so you'll see that a little bit in the flow. There's currently, I think, 67 APIs when I last checked, and each of them have multiple different versions. They are all listed on the website. But if you have other questions, feel free to come find me after. So as an example, this is the kind of thing you'll see on the website. So this is for producing. This is version 0 because it was smaller and could fit on the slide better. And you'll see there's specific protocol types. So the records here is like a custom type. And all of the information is, again, in the docs for Kafka. So let's look at rebalancing. How does this work? So when a client wants to join the group, first it has to find the coordinator. So both Kafka and Connect have this idea of initially you don't have to connect to any particular member of the cluster. You can connect to whichever you want. So the client connects to Kafka and says, please tell me which the coordinator is. And the Kafka cluster, the broker in question, will return with, it's this one and it lives here. And then the client can join the group. And from here on out, pretty much all of the requests go to that group coordinator. So all of the clients find their coordinator and they join the group. And then the coordinator will elect a leader. And this is the interesting thing. Kafka decided, actually, we're going to have one of the clients be leader, and they're going to decide the assignments. So at this point, all of the clients sent some sort of metadata about what resources they were interested in, and those were given to the leader. And we then have a request that comes back, which is sync group with those assignments. Now, the reason all of these have to go, the reason they all do the sync group, is because of this whole request response thing. So we had the join group, and then the response is, cool, you're part of the group. Oh, and by the way, here, you're the leader to the one that's the leader. And then they all send a sync group where the leader also includes the assignments. So then the response to the sync group is, here are your assignments. And then off they go, the clients will start processing those assignments. So the other thing the coordinator needs to be able to do is to notice if we get new members of the group or if a member isn't there anymore. And we do this using heartbeats. So every now and again, the clients will send a heartbeat to the coordinator to say, I'm still alive, I'm still processing data. So what have we got here? We've got firstly our group coordinator, and this is a Kafka broker. It's in charge of selecting a leader, sharing assignments with the members, and triggering rebalances. Then we have a client, which is a member of the group, and that chooses assignments for the members, if it's the leader, and all of them will then start work based on an assignment. But why have the client as the leader? I think if we were looking at this from the beginning and saying, okay, we need a mechanism to decide how to distribute these resources, it would have been really easy to say, well, let's just have the broker do it. The clients should just join the group and then they get told, here's your assignments. It would be a lot less back and forth. But that's not what they decided to do. Instead, they've decided to have one of the actual clients be that leader and make the decision. And the reason they did that comes back to how the protocol is chosen between the different clients. So there's this additional protocol that I haven't really mentioned, where the clients will share protocols that they support, and the broker will choose a protocol. And what I mean by protocol here is the broker actually has no idea what the clients are doing. It has no idea if it's from a consumer group. It has no idea if it's a worker for Connect. All it does is say, okay, you're part of a group. You've said you want to work with this protocol called this thing. Cool, that's fine, we'll do that. It's the clients that have all the logic of understanding what that means. And you can see this if you actually look at the API. So this is join group, and you can see we have a protocol type, and then the protocols. And also within the protocols, there's metadata. So I kind of mentioned earlier that when you do a join group, you send some information about what you're interested in, and that's part of the metadata. So what does this mean? Well, it means for our consumer groups, we have a protocol type of consumer. And we have a metadata of a list of topics. And then for Connect, we have a protocol type of Connect, and the metadata is the connector and the task config. So by making the decision to say, actually, I want the brokers to only know about membership, they've been able to have these two different mechanisms that is just built into the clients. And this gives a few different benefits. So we now have one group membership protocol. So if you go and look at Kafka, within the brokers itself, they just understand the group membership protocol. They don't have to worry about any assignments. And then you can have multiple different assignment protocols at the lower level. And what this means is when you get a new assignment protocol, it only requires a client upgrade. So if you wanted to add a set of new assignment mechanisms, you just have to update each of the clients that's part of the group, and once they've all updated, the broker will then say, okay, cool, you've all said that you prefer this protocol, so that's the one you're going to use, and then the clients will use that. And it also means that customization is done client-side, not broker-side. And this is really useful, particularly now where we're seeing more and more people running Kafka, perhaps managed, perhaps somewhere where they can't really access it. It means that if you want to, you can actually implement your own assignment protocol and do something completely different from what's currently happening with the consumer groups without having to change anything on the broker side. You just run your client and it will do the right thing. And this is where it comes to the update that's happened in actually all of the clients, but I'm going to focus on Connect. So by having this mechanism of the broker not really being aware of how assignments are done, it's enabled the Kafka community to update the Connect workers to improve the way they do rebalancing without having to change anything broker side. So let's look at why this was needed. Well, when you're running with Kafka Connect and you have all of your connectors. So say you've got a connector with 2 tasks. Let's say we've started another connector, and we've said it's going to have max task 1, so it's just going to have 1 task. The flow that happens is the worker will then send a new join group to say, I've got some new metadata. There's this new task and connector that needs starting. When all of the clients then heartbeat, the coordinator will say, I've been informed that we need to update here, so we're going to do a rebalance. Then what will happen is all of the workers will stop processing data. They send a new join group. The leader is informed that it's the leader. It computes assignments, sends the sync group, distributes the assignments, and then everything starts back up. So this is not ideal, because it means that actually, if I'm running one connector, connecting to my system over here, and I decide to start a new connector doing something else, I've had to stop all of the work, wait for everything to rebalance, and then start back up again. If I'm only running 2 connectors, maybe that's not the end of the world, but what if I'm running like 50 connectors or hundreds of connectors? It's really not a great way to do things. So the Connect community decided recently to update this. So this is the way it works now. If you run Connect, this is the default behavior. So again, we get this request come in, and we get the metadata update, and they heartbeat, and we trigger a rebalance. This new mechanism is called incremental cooperative rebalancing. So what this means is, instead of doing a stop the world, stop everything, and then restart, it's going to incrementally get to the end goal. So all of the workers rejoin with their previous assignments. They say, this is what I'm currently running, and they don't stop doing anything. They're still processing in the background. Again, the leader is informed, and it computes the new assignments based on this new metadata. So remember, we're starting a new connector. The result comes back, and the information that comes back down to the connectors has been updated. So this is the information that the worker will send that is the assignments. It's been updated to include these 2 fields, revoked connector IDs and revoked task IDs. So what will happen in this case is we say we're going to distribute the assignments, and none of these had to revoke any of the tasks. They could just add the new tasks, and we're pretty well balanced. So in this flow, it's definitely a step up from where we were before, because we haven't had to stop the world. But if, say, worker 3 was told that it had to stop processing task 2 and to start processing task 1 of connector 1, what it would do is it would at that point stop processing and then do a rejoin of the group with blank as its assignments, because it's currently not running anything. And then we would go back and forth, group rebalance, and when it gets its assignments, it would get its new assignment, and it would start its new task. So the reason it's called incremental is because we don't do that big bang approach. We, step by step, we first take down the things that we aren't supposed to be processing anymore, and then add the ones that we are. And again, this is an interesting choice. So there are other mechanisms within, say, the consumer groups that have looked at reducing the number of rebalances. But this is actually just doubled down on rebalancing. If you've got lots of the tasks moving around, every time you have ones that are being revoked, you're having to go back and forth and rebalance lots. But because we're not actually stopping any of the work, it makes rebalancing really lightweight. And you can actually see all of this happening. So some of you might not be aware, in the REST API for Connect, there's actually a really cool endpoint which helps you edit logging just straight away there on the endpoint. Obviously, as you've all been in the keynote, you need to make sure you secure this endpoint so that you don't have lots of logs being filled up. But this is the default response, but what you can actually do is add logging for a specific class. So this is the incremental cooperative assignment that's part of Kafka Connect. And if you run this command to update the level to debug, then you can see all of this happening in real time on your Connect workers. So you can see here we've got performing task assignment, what the previous assignments were, so you can see the connector IDs and task IDs, and then you can see the assignments that come through and whether or not they've got revoked IDs as well. So this is definitely worth taking a look at, and you can really see it kind of going back and forth. So with that, I'm going to summarize. First of all, don't be afraid to iterate. I think that the way they've got to this rebalancing is a really interesting example of how actually you really aren't going to get things right the first time. the original rebalance that I talked through with Connect wasn't even the first version of rebalancing within Kafka. But by keeping on going and looking at how they could continually improve, they've got to what I think is a much better flow now with the incremental cooperative rebalancing. But you should be bold in your API decisions. It wouldn't have been possible to build this new mechanism and have it so lightweight going back and forth with the rebalancing if it wasn't for that initial choice of saying, actually, we don't think the brokers should care about how these resources get distributed. We think it should be on the clients that are actual members. And when they originally made this decision, I think there was some question of, well, isn't it simpler if the broker just knows everything? But actually, I think this has made it better within Kafka. And the final one, of course, is Connect and Kafka are really awesome. Hopefully you've seen through this presentation that particularly Kafka Connect, they've really thought about how to make it easy to get started and how to make it really easy to customize your different flows. Connect isn't the ideal solution for every use case of getting data into and out of Kafka, but it is great for lots of them. And if you want to take a deeper dive into Connect, I'm going to do a plug here, which is I'm writing a book. So with my colleague, Mikkel Mason, it's not going to be released for a little while yet, but there are 4 chapters available in early access on O'Reilly. So if you are interested in having a read, please do, and we'd love to hear feedback as we're writing it. So that's everything that I had time for today. Thank you. And I think I've left about 5 minutes for questions, if anyone has any questions about Kafka, Connect, or anything else. Anyone? Yeah?
Yeah, the protocol that is used to add a new worker looked actually very similar to the additions to the consumer group resolution.
Yeah. Yes.
Is there similarities? Is there the thought the same, or is also the code the same?
Yeah, so the underlying code is different because of the different metadata that's going back and forth. But actually, yeah, so what the Kafka community have done is it was really in Connect that they noticed this problem, because in Connect it's much more obvious that it's a problem. Initially, people were using Connect and saying, well, Connect is great, but you need to decide how many connectors you run up front, and then leave them like that forevermore, otherwise you're going to cause mayhem. So they decided to introduce the incremental cooperative rebalancing. But actually, yes, they've now introduced that for consumer groups and also for Kafka Streams, which also uses the group membership. So it's been interesting to see that by having it separate and having the different clients all use the same mechanism but with different resources, that they've been able to notice a problem somewhere and then go, actually, this will probably happen in all the other places as well. So if you actually go look at the KIPs, you can kind of see they link through to all the different ones. You can see the different like subtle choices they've made. They're all sort of slightly different depending on the use case. Are there any other questions? Or have I just thrown a lot of information at you? Okay, well, if you do think of any more questions, I'll be around for the rest of the day. I'll probably go over to the Red Hat booth a bit later. And you can always reach out to me on Twitter as well. And if you really don't want to talk to me on Twitter, then if you do go and have a look at the book, then there's an email there to email like questions and stuff. So if you have any more general Connect questions, then you can always message me there as well. Cool. Thank you very much.